Okay, so before Easter we were talking about scalar quantities and vector quantities. So just a quick review, scalar quantities are any measured value that has only a magnitude. So distance is one. So if I say that it's 350 kilometers to Edmonton, that is a distance. Okay, if I say it is 350 kilometers at probably like 10 degrees east of north, okay, to Edmonton, then I would be giving it displacement, which is a vector quantity because it has both magnitude and direction. Okay, everybody follow me there? All right, we said the same relationship exists between speed and velocity. Speed is scalar. How fast are you going? 120 kilometers an hour. Okay, what's your velocity? 117 kilometers per hour at 15 degrees east of north. Okay, whatever. Okay, that's going to be our that's going to be a vector quantity. Okay, so magnitude and direction, then you've got a vector quantity. Just magnitude, you've got a scalar quantity. Right? Time is a scalar quantity. Right? As is things like mass, energy, stuff like that. All right, so we're going to kind of go through a little example here of this idea, kind of the similarities and the differences between distance, displacement, velocity, and speed. I think we did this before the break, but it's worthwhile to go over it again. So let's say I want to walk to Walmart for whatever reason, okay? But that's what I want to do. So I want to go from my house has one window and one door, apparently. Okay, so I want to go from my house and I want to walk to Walmart. Okay, can I walk straight? You don't know where I live, and I'm not going to tell you. Is it likely I can walk in a perfectly straight line to Walmart from my house? No, like even the houses right behind Walmart still have a fence. Okay, like you still have to go around the fence or over, but it's no longer a straight line if you have to do that. So let's say I'm going to walk from my house. So I'm going to, come out of my house and walk along the sidewalk, and then follow the path, and do this, and then cross the bridge across the river, and then keep going to Walmart. Okay, and eventually get there. Okay, so that red line represents the distance that I would have to walk. How far would I have to walk? Okay, let's say that distance is 4 kilometers. Okay, I don't give a direction on that because I went a whole bunch of different directions. That's a squiggly line. Okay, but in total, when I get to Walmart, I will have walked 4 kilometers. If I'm keeping track of it on my watch, okay, or something like that, then it's going to tell me 4 kilometers when I get there. Everybody okay with that? Okay. Now, displacement is your change in position, and it's that straight line. Okay, that's why it has both magnitude and direction, because it's going to be a straight line from my house to Walmart. It's going to tell me exactly how much I have displaced myself, or how much I've changed my position by. Right, so a line that represents my displacement would look like that. Is that shorter than 4 kilometers? Yes, definitely shorter than 4 kilometers. So the displacement to Walmart, we'll say, is going to be 2.8 kilometers at 38 degrees. Well, I've got north of west, but that's definitely not the way I went. It's actually, I'm going to change the vector so it's a little bit more accurate. Okay, let's say at, let's say 20 degrees south of east, because that's which way I went. Okay, let's say that took me 1 hour. Sorry, a half an hour. It took me a half an hour to walk to Walmart. What's my speed? How fast did I walk? I went 4 kilometers, and it took me a half an hour. How fast did I walk? 8 kilometers an hour. Okay, so in order to do that, okay, we did this calculation. We said the speed equals the distance divided by the time, okay, which is going to be 4 kilometers divided by 0.5. So 4 kilometers divided by 0.5 hours, okay, gives me a speed of 8 kilometers per hour. Okay, everybody all right with that? Okay, what's my velocity? Okay, so velocity is going to be a vector quantity, and it's displacement over time. Formulas look very similar. Okay, all vector quantities have a little arrow over top of them. Okay, so that's how I can tell speed and velocity apart. Speed is a v with no arrow. Velocity is a v with an arrow. Okay, d is distance, no arrow. D with the arrow is displacement because it's a vector quantity. All right, so if I want to figure out what my velocity is, then I'll take my displacement, 2.8 kilometers at 20 degrees south of east, and divide it by half an hour. Okay, because regardless of which way I look at this, the time from my house to Walmart is a half an hour. Okay, everybody all right with that? Okay, so when I do that, I'm going to get that my velocity is 5.6 kilometers per hour at 20 degrees south of east. Okay. My velocity and my displacement have to have the same vector. Okay. I can't possibly end up east by walking north. Okay. So if I say my displacement's 10 kilometers east and my velocity is 25 kilometers per hour north, there's no way. Okay? That's basically like saying if I walk this direction, I'll end up over there. No, I won't. Okay? I will absolutely not end up over there. Okay? So your velocity and your displacement have the same vector. Mathematically, the reason for that is there was nothing to cancel it or change it. Okay? I changed kilometers divided by hours, so kilometers per hour, but the direction stays because there's nothing mathematically to change or eliminate. Okay, everybody all right with that idea? All right, now, because I'm old and forgetful, I get to Walmart and I realize I don't have my wallet. I'm not going to walk around Walmart for the fun of it, okay? So I just turn around and walk exactly the same route home. When I get home, what will my total distance traveled be? 8 kilometers, because I'm going to follow exactly the same path back. Okay, if it was 4 kilometers there, it'll be 4 kilometers back. So my total distance traveled, okay, will be 8 kilometers. Whoops, I gotta use the right color. Okay, and let's say that when I get back, it was another half an hour, so my total time is an hour. What's my speed? 8 kilometers per hour, right? It doesn't change. Okay? So my speed is still going to be my distance divided by my time. 8 kilometers divided by 1 hour, okay, is 8 kilometers per hour. When I get home, what's my displacement over the whole trip? 0. Okay? Displacement measures how much you change your position by. My starting position is home. My ending position is also home. Therefore, I haven't physically changed my position over the whole trip. Yes, I walked to Walmart and back. A scalar description reflects that. It says that I did walk 8 kilometers and it took me 1 hour. But a vector description looks at where I started and where I ended. And it says, you accomplished nothing because you're back where you started. Okay? So my total displacement, if I walk exactly the same path and end up back at home, is 0. Because we calculate displacement by taking our final position and subtracting our initial position. Well, they're the same number. What's 2 minus 2? 0. That's what we're doing here. My final position, home. My initial position, home. Done. 0. Didn't go anywhere. Okay? Now, what's my velocity over the whole trip? get to Walmart. But now when I get home, you guys just told me my displacement is 0. So if my displacement is 0 and I divide that by 1, what do I get? What's 0 divided by anything? 0. My velocity then is also 0, because from a vector standpoint or a vector point of view, I have gone nowhere. An hour has passed and I'm back where I started. Okay? So my average velocity over the whole trip would be 0. Okay? Because my displacement is 0 divided by 1 hour. Okay? Well, it's still 0 kilometers per hour. Okay? And there would be no direction on that because I haven't gone anywhere. Everybody all right with that idea? Okay? This is an important thing for us in terms of like application. In your car, there's a little meter called the odometer. It tells you how many kilometers your car has been driven. Okay? Does it measure distance or displacement? It measures distance, and it's a good thing it does. I would not want to buy a used car if its odometer measured displacement. Because if I went to the person's house or I bought it at the dealership it was originally purchased at, what would it read? Yeah. Okay? If I bought it from somebody's house, it would read how far it was from the dealership to their house, because the dealership would be its initial position and the house would be its final position. If I bought it from the same dealer it was bought from, it would read 0. They'd be telling me, hey, brand new car, dude. That car could have been driven around the world 3 times. If it read displacement, its odometer is still going to read 0, even though the distance it's been driven is hundreds of thousands of kilometers. Okay? That's exactly why the odometer doesn't do that. Okay? Nobody wants to know the displacement of the car. They want to know how far did somebody drive this thing. Is it about to fall apart or is it like new? Okay? We need to know that. That sort of makes sense to everybody? Okay? That's kind of one of those things. And your speedometer, it reads your speed. It's not a velocity meter. Okay? It reads your speed. It tells you how fast you're going. Your car changes direction all the time, but your speedo stays the same. Okay? Your speedometer would have to be like a 3-dimensional rolling ball, okay? Kind of like a compass ball, in order to actually like give you a reading of velocity. So anytime you turn, the ball would roll and it would be really weird. Okay? It'd be very difficult to read it. All right. So difference between scalar and vector starting to make a bit of sense? All right, so we just did that, so we'll skip that. Okay, using V equals D over T. So a little bit of rules of algebra again. Okay, I taught you the 3 rules of algebra back in the chemistry unit, but I'm going to review them today. Okay, we need to be able to manipulate equations in Science 10. Okay, we cannot use triangles to manipulate equations. Okay, while a triangle would work for a 3-variable formula like that, that's the last time in this course it'll work. Okay, the next like 3 formulas we go over, a triangle won't work for. Okay, so if I want to manipulate V equals D over T, so right now it solves for V. What if I want to solve for D?
U times the equation by T.
Right, I would multiply both sides by T. Okay, T times V equals D. All right, everybody okay with that? All right, what if I want to solve for T? What would I do? We didn't have to do this one in chemistry because we always had molar mass and it was on the bottom. Okay? If we want to solve for something, it can't be underneath something else, because then you're solving for 1 over it. You're solving for its inverse, but not the same thing. Okay? So if I want to solve for T, the first thing I want to do is multiply both sides by T, and then do what with the V?
The other side.
Yep. Divide both sides by it. Okay? Remember, our rules of algebra are, if I want to move something, I do the opposite operation. What I do to one side, do to the other side. and I move what's not attached first, which won't apply to this formula, but it will apply to the next one. Okay, so those are the three rules of algebra. So when I want to solve for d, okay, right now, it means I have to move t. Right now I'm dividing by t, so I multiply both sides by t, and I'm solving for d. Everybody okay with that? Okay. And if I wanted to solve for t, then I would divide both sides by v. Okay? So all we're doing is following those basic rules of algebra. Rika, you're looking at me like I said something wrong. Did I confuse you?
Yeah.
Okay, what's going on? Which part did I lose you at?
How do you get the D and T?
Okay, let's start. Whoop. Oh, that's not what I wanted to do. Let's start over here. Okay, so how did I get D?
Yeah.
Okay, so in order to isolate D, I have to get it by itself. T is on the same side as it is right now, so I need to move T over here. To move something, I perform the opposite mathematical operation. So right now I'm dividing by T. The opposite of divide is multiply. So if I multiply this side by T, there's a T on the top, a T on the bottom, and they cancel. Because T divided by T is 1, right? So they cancel. What I do to one side, I do to the other. Yeah? Okay. All right, everybody okay with that? Now, let's have a look at this formula here. Right now, that formula solves for y. Let's say I want to solve for m. Okay? This is the next formula we're going to use. This is the equation of a linear graph. Okay? You've probably seen it in math. Let's say I want to solve for m. What should I move first? I should move b first. Okay? The third rule of algebra is move what's not attached to what you're looking for first. X is attached to m, b is not. Okay, so I'm going to move b first. Right now I'm adding b, so the opposite would be subtract b. All right, so if I subtract b, b minus b is 0. Done. Okay, and then I'll have y minus b. What I do to one side, I do to the other. All right, so now I have y minus b equals m times x. I want m by itself. What do I have to do with x? Divide by x. Okay, so I'm going to divide this side by x. X divided by x is 1. Divide this side by x. Done. Solve for y. Okay, everybody all right with that one? Okay. What if, instead of that, what if I wanted to solve for b?
Would you subtract b and subtract y on either side?
I could do that. If I do that, though, I'll be solving for negative b. Okay, here's why. If I subtract b from both sides, so we'll be back to this, y minus b equals m times x, okay? If I want to move y now, I'm subtracting, right, but y is positive, so I would have to move it over by going like this, but that's going to leave a negative there, right? And that's okay, it'll work, but I have to remember that whatever number I get is the opposite of what I was looking for. Okay?
Can you just times both sides by negative 1 to make it even?
Yep, I can do that too, but I have to remember to do that. That's what I'm saying. Like, I have to remember that the sign is opposite of what I'm looking for. I have to remember to do that. I'm terrible for that, which is why I never do it that way. Perfectly valid to do it that way, okay? But what I usually do, okay, is I say to myself, self, if I was doing order of operations, I would multiply these two numbers together before I added it to b. So really, this is like A plus B. Could I just subtract this over to the other side? I could. I can just go y minus m times x equals b. And be done. Then I don't have to worry about, multiplying by -1 or that I solve for a negative number. I solve for b and it was positive. Okay. Little tricks with algebra that we'll learn as we go along. Okay. Now, after that formula, the next formula we're going to use is this one. That's a subtraction, not a dot. Okay, let's say I want to solve for VF. What should I move first? T. T is not attached to VF. Okay, right now I'm dividing by T, so to move it I would okay, T times A equals VF minus VI. I want VF by itself. What do I do with VI? Add it to both sides. Okay. Guys, I will not say that I am the strongest mathematician out there because that's so not true. Okay? I had my struggles with math as well. Okay? I don't ever say math is hard, okay? Because I don't believe that. Okay? I believe people are inherently able to do math. Not everybody's going to be brilliant at math. I would never say that. Okay? But I would also say that people are not inherently bad at it. Culturally, unfortunately, we've been told that. Okay? We've been told culturally, math is hard. I suck at math. And that's what everybody thinks, or not everybody, but lots of people think about themselves in math, which is so not true. Okay? This is just basic algebra. Okay? I got through university physics with those 3 rules. And so can you, as long as you don't take calculus-based physics. Then that's all different. Then you got to be good, really good at math. Okay? But to just be able to do this kind of thing, it's 3 rules. It can get you through an awful lot of complex stuff. Okay? But you can do it. It's just 3 simple rules. Okay? And we're going to practice that. We're going to get lots of time to work on it. All right. So those are the 3 rules of algebra. I think I gave those to you in chemistry, but maybe it's not a bad idea to write them down so you have them in your physics section of your notes. Okay, I'll give you a couple minutes to get those written down, and then we're going to move on to some problem solving. Okay, oh, I had it twice. All right, I want you guys to write this one down. Okay, and we're just going to walk through it together here. It's simple V equals D over T calculation. So if we're solving a question like this, just like when we did the mole equation, we want to write down what the question gives us first. Okay? First thing it says is, how far will a deer run? Okay, so how far? Is that looking for distance or displacement? Distance. How far is distance? If it said how far and in what direction, then we'd be looking for displacement. All right, so we're looking for distance. Okay, how far will a deer running at 15 meters per second? What did they give me there? Okay, speed, velocity, time, what did they give me? Speed. How do I know it's speed and not velocity? If it was velocity, what else would there be with the 15 meters per second? The direction, and there wasn't one. Okay, and how far will it travel in 45 seconds? Well, seconds are a unit of time, right? So I kind of have to look at my units and a bit of the context of the question to figure out what the numbers are that it's giving me. Okay, units is probably the most reliable. All right, so that's what I'm given, and I'm being asked to find D. So you get a mark for your givens, okay, just like you did with the mole equation. Okay, now, in this unit, okay, one of the reasons we give you a mark for your givens is because it's going to help you select which formula to use. There's only one formula on the back of your periodic table with the formula sheets that has well, it's actually not true, there's two. Okay, that have v equals d over t. Okay, one's to calculate velocity, the other's to calculate speed. We need the one to calculate speed. All right, so I've got this. Now, I'm looking for d. So what do I have to do? Multiply both sides by t. So I'm going to have t times v equals d. All right, so you'd probably get a mark for choosing the correct formula. I mean, at this point, it's obvious we've only talked about one formula. Okay, and then you'd probably get a mark for your manipulation / plugging in of your numbers. 45 times 15. Okay. We go 45 times 15. What are we looking at? I'm not doing that in my head. 450. Okay, 675. 675 what? Meters per second measures how fast I'm going. I'm solving for how far. Meters, yeah. Okay, now I'm going to show you why that works. Okay, why this comes out to meters. When I multiplied time and speed, okay, I took seconds and I multiplied it by meters over seconds. Okay, so is seconds the same as saying seconds over 1? It is. Okay, so seconds times meters is second meters. I don't know what that is, but that's okay. Okay, and 1 times seconds is seconds. Seconds on the top, seconds on the bottom, what do? Okay, so I'm left with meters. Okay, so you can always kind of do a check at the end to make sure you have the right units, but I mean distance is always going to be in some unit of length. Centimeters, meters, kilometers, something along those lines. All right? Everybody with me on how that one worked? So that would be like a 3, maybe 4 mark question. Okay, I want you to try this one, and then we'll go through it together. All right? This one we're looking for how long it will take a tortoise to crawl 200 meters at 0.25 meters per second. All right, so like we said before, first step is to write down all of our givens and what we're being asked. How long will it take? What am I being asked to find? Time. Okay, will it take a tortoise to crawl 200 meters? What did they give me there? Distance. And I know it's distance and not displacement because it doesn't have what? No direction. Okay. And then it tells me it's speed of 0.25. So they tell me it's speed right out. Okay, 0.25 meters per second. Okay, and typically in physics, we use meters per second. Okay, kilometers per hour is more of like an everyday kind of thing. Okay, but in physics, very, very much of the time, we're talking meters per second, even when we're talking about really fast things like the speed of light. Okay, it's 3.00 times 10 to the 8 meters per second. Okay, generally everything's in meters per second. All right, so I've got D, I've got V, I'm looking for T. So V equals D divided by T. I need to get T by itself. I cannot solve for something if it's on the bottom of an equation. So I'm going to multiply both sides by T, make it come over here, and then to get T by itself, I'm going to divide both sides by V. So I'll be left with T equals D over V, and that'll be 200 meters divided by 0.25 meters per second, which should be 800 seconds. I think that's right now. Okay? All right. Now, if we look at our units here, okay, I mean, first off, I was looking for time, so I knew the unit should be seconds. But if I wanted to confirm that, meters divided by meters per second, the meters cancel, and I'm left with seconds. Okay? All right. Questions on that? All right. I want you to write this one down, but we're going to walk through it together. I'm not going to have you try it on your own because this is our first two-part question that deals with now vectors. Right? So how many parts are there to this trip? 2. Right? So what we have to do is break up our givens and break up the trip into 2 parts. Okay? So I'm going to write down here, here's the information I have for part 1 of the trip. Okay? It says that in part 1 of the trip, the bus traveled 100 kilometers north. What did they just give me? A displacement, right? Okay, and it did so in 1.2 hours. Okay, so they just gave me a time. Okay, and then it says they turn. Okay, so now we're dealing with part 2. They turn and travel 62 kilometers south, which is another displacement. In 0.9 hours. What is the average velocity of the bus? Okay, now, what a lot of people do at this point is they do extra work that's wrong. Okay? What they do is they calculate the velocity for part 1, they calculate the velocity for part 2, and then they take what they've learned about calculating averages and apply it to this situation. How do you calculate averages? Like if I wanted to calculate the class average on a quiz, how would I do it? Exactly. Okay? That's exactly what I would do. I would take all of the scores in the class and divide by the number of scores. There are a number of people in the class, and I would have the average. And that's fine, as long as every part of my calculation represents an equal amount of the whole. And every one of you represents an equal amount of the class. So I can take all of your scores, add them together, and divide by the number of people. I cannot do that here. Okay? If I take the velocity from part 1, and I add it to the velocity from part 2, and divide by 2, I am saying these 2 parts of the trip are equal parts of the trip. They're exactly 1/2 of the trip each. Are they? No. Okay? This one is 100 kilometers. This one is 62 kilometers. It is like 1/3, less than 2/3, okay, of the whole trip compared to that. Okay? Does everyone follow me on that? Okay, so it is definitely not. They are definitely not equal. So what I do instead is I look at what this formula really means. Okay, velocity equals displacement divided by time. What this really means is average velocity is total displacement divided by total time. How do I get totals? What mathematical operation?
Well, you just like add the two.
Exactly. I add it. Now, I have to keep in mind that one is north and one is south. So one of them has to be, how do I represent things that are opposite mathematically? Negative. Okay? One of these things has to be negative. North is usually positive, south is usually negative. Okay? So what I would do here is find my total displacement. So I would go 100 kilometers north plus negative 62 kilometers, because negative north is south. We just never write it as negative north. I never say, hey, I'm going to go to Lethbridge because it's negative north from here. So people just don't talk that way. Okay. What do I do with the times? I'm looking for total time. What should I do with the times? Same as the distance with one exception. Is time vector or scalar? it's scalar. So I don't make the time for part 2 negative. Okay? If I do that, I'm saying that not only did they go south, but they went back in time as well. Okay? Which would be really cool, but not what's happening here. Okay? Time is scalar. It can't go back. Time can never be negative because that means I actually went back in time. Okay? So I would take my 1.2 hours plus 0.9 hours. So what I end up with here is that I have V equals 38 kilometers north. Okay? Because 100 plus negative 62 is 38. Okay? And then divided by 1.2 plus 0.9, which should be 2.1 hours. Okay? Can I now calculate what my average velocity over the whole trip is? I can. Just have to go 38 divided by 2.1. Okay. 18.1 kilometers per hour north. Okay, because I went 100 kilometers north. I went 62 kilometers south. That means I'm still north of where I started. Okay. So what really happened in this question is that in part 1, the bus did this. In part 2, the bus did this. Okay. This right here would be my initial position. This would be my final position. Okay? The displacement is the change in position. Okay? And it would be 38 kilometers north. I still end up 38 kilometers north of where I started. Okay? In Science 10, that's as tricky as vectors are going to get. You're only ever going to have what we call one-dimensional vectors, north and south, east and west, okay, up and down, okay, positive and negative, right? All of that, forward and backward. Okay? That's all we're ever going to have. We're never going to go off to the side, because if you go off to the side, you're going to have to do trig. Okay? We save the trigonometry for physics 20. Right? We're never going to have to do trigonometry when we do our vectors and scalar stuff in Science 10. Okay? So, if you have a multi-part problem, this is what you do. You write down the givens for all the parts, and then you try and work towards a total. Is that part of the question? No. Okay, could I also, in this question, ask for the average speed of the bus? I could. I gave you enough information to find it. Okay? We said the bus went 100 kilometers north, then it went 62 kilometers south. Can I figure out how far it went? How far did it go? 162 kilometers, right? Distance doesn't care whether we went north or south, just how far did we go? Okay, so to calculate average speed is very similar. It's total distance divided by total time. Okay? We just don't have to worry about north and south anymore. Now it's just 162 kilometers divided by 2.1 hours. Okay? We're going to get a much different number for our average speed. Okay? 77 kilometers per hour is the average speed of the bus. Right, everyone following the difference there between velocity and speed, distance and displacement? Alright, I want you guys to try this one. It's exactly what we just did with a different context. It wants you to find the average speed and the average velocity. So break it up into the two parts. So have like part 1, part 2, and then a total. Okay, and see how you do. We'll give you a few minutes on that one, then we'll walk through it together. All right, so same as the first one, we want to break this up into the two parts. We got part 1, okay, we got part 2, and then we got our total. Okay, in part 1, part 1, the rabbit runs at 22 meters per second east. So they gave us a velocity. Okay. It could also be a speed if we take the east off and assume that this was a straight line, which it doesn't give us any reason not to think. Okay. And it does that for 12 seconds. Okay. And then in part 2, it turns and runs due west at 17 meters per second for 32 meters. Whoops, west, not east. Okay, what's its average speed and average velocity? Okay, so if I want to get average speed, I need the total distance and the total time. And if I want average velocity, I need the total displacement and the total time. Okay, what don't I have in part 1? I don't have the distance or displacement, which is what I'd be calculating here because they gave me velocity. Okay, and in part 2, I don't have the what? The time. So I can't get the total distance and the total time. I can't get the total displacement and the total time yet. Okay, I have to calculate what I'm missing in parts 1 and 2 first. All right, so I need to calculate d. And if I manipulate v equals d over t, to get d, that just means I multiply both sides by time. Okay, so d will equal v times t, so that'll be 22 times 12. Okay, so that's going to be a displacement that I'll be calculating there. Okay, so 22 times 12. 264 meters west. Okay, in part 2, I need the time. V equals d over t. If I'm solving for t, I'm going to bring t over to this side by multiplying both sides by t, then divide both sides by v. So t will equal d over v. That'll be 32 divided by 17. Okay, 1.88 seconds. All right, everyone follow what I've done so far? Okay, so now I've got t for both parts, I've got d for both parts. Now I can do that average speed and average velocity calculation that I couldn't do a minute ago because I didn't have d for part 1 and t for part 2. Okay, so sometimes you'll run into a question like this where you've got to do some intermediate calculations to get the rest of your information. Okay? All right, so if I want to find the average speed, I need the total distance and the total time. So this here was a displacement. Could it also be a distance? It has to be because they didn't tell me that the rabbit ran in a crooked line, which is, I get what a rabbit usually does. Okay, but it doesn't say that it didn't run in a straight line, so I can say that in part 1, the displacement was 264 meters west, but the distance was 264 meters. Okay, and then in part 2, it ran another 32 meters. Okay, so I can calculate my total distance. So v equals total distance, which will be 32 plus 264 divided by the total time, which will be 12 plus 1.88. Okay, so we're going to have 296 divided by 13.88 for our average speed. All right, so the average speed of the rabbit is 21.3 meters per second. Okay, and all we've done is take our total distance and divide it by our total time. Okay, how is that calculation going to be different to calculate the average velocity? I'm only going to change one thing. instead of adding these two numbers together, and actually I have them in the wrong order, okay? Instead of adding those two numbers, now I have to recognize this 264 was east, and the 32 was west. It's backtracking. Okay, so like the rabbit literally does this. And it turns around and comes back tiny little ways. Okay, and then that's it. All right, so all I have to do is change the addition to adding a negative so that I reflect this one's west and that one's east, and then do my calculations. So I'll have 232 divided by 13.88. Time doesn't change. All right, so we're looking at 16.7 meters per second east. Okay, this is velocity, vector quantity. Okay, I went 264 east and 32 west, so I still ended up way east of where I started. Okay, everybody all right with that? They don't get much trickier than that, okay? Unless I was to make one that had 3 parts, but it's still the same steps. You just have to do more of them. Okay. That's all there is to those. Okay. Questions on that one? Okay, so just quick review here. Scalar quantities, remember, have magnitude only, okay? Speed, distance, mass, time, okay? Vector quantities have magnitude and direction, displacement, velocity, okay? Acceleration, okay, are going to be ones that we'll deal with that are vector. Okay, there's an easy one. We've done a couple like that already. That is like totally as easy as they would ever get.
For the quiz tomorrow, so just leave it like the question with this.
It might be a little trickier than this one,
Okay, yeah.
but yeah. V equals D over T for sure. Didn't take you very long. Okay, so all we have to do for this one, obviously write down our givens. Distance is 100 meters, okay? Time is 20 seconds, and we're just looking for V, okay? V equals D over T, so all we have to do is plug in the numbers here. 100 meters divided by 20 seconds, okay, is going to give us our 5 meters per second. Okay? Everybody all right with that one? Okay. All right, this one, it's like fairly easy, but there's one thing to be mindful of. A little bit of metric system conversion involved here. Okay? If I've got a speed that's in meters per second, and I've got a distance that's in kilometers, what do I need to do to the distance? Make it to meters. My units have to match, okay, before I do any other math. Okay, remember that kilo means 1,000. Okay, let's quickly look at this one here. Okay, so we're looking for how long it will take. So we're looking for a time. Okay, and it tells us that the jet is traveling at 330 meters per second, which incidentally is the speed of sound at 0 degrees Celsius. Okay, and we know that the distance is going to be 400,000 meters because there are 1,000 meters in a kilometer. Okay, so V equals D over T. I'm looking for T, so I'm going to multiply both sides by T, divide both sides by V. T will equal D over V. 400,000 divided by 330. It's going to take 1,212.1 seconds. Okay, can you leave it like that? Can you leave it with a big number in seconds? Absolutely. Unless the question specifies they want it in minutes or hours, don't do extra work. Okay, it did not specify what the units for time had to be, so you go with what it gave.